Hi guys, today we're on page 17 and 18 in your notes. Basically, we're just going to go over, I think, 3 problems and just talk about when we have different representations, how we can still figure out, the equation, the graph, the table, or the verbal description from all of that. So on page 17, on this first problem, we have this verbal description. So we have a baby giraffe that measures 6 feet tall when it's born, and it grows an average of half a foot every single month. Okay, so if you're ready to write the equation, we could, or we could wait and write the equation later. That's totally fine. I'm going to do the table and the graph, and then we'll write the equation. Okay, so X is the number of months that the little giraffe's alive. And then our output is the height of the giraffe. So how tall does the giraffe get? Right? So when the giraffe is born, okay, it already starts out as at 6 feet tall. Okay. After 1 month of being born, it grew a half a foot. So if it was 6 feet, it would be 6.5 feet. And I'm just going to write 6.5. Okay. If it's 2 months old, it grows another half foot for 7 feet. For 3 months, it would grow another half foot. 4 months, it would grow another half foot. 5 months, it would grow another half foot. And at 6 months, it would be a total of 9 months or 9 feet tall. Okay. So our equation would be y equals, starts at 6 feet, okay, and grows a half a foot every single month. Okay. Obviously, if you want it to look like mx plus b, you could write 1/2 x plus 6. Okay. So what we're going to do is we are going to graph this relationship. Okay, so we're going to start at 6. 1, 2, 3, 4, 5, 6. So this is where the giraffe starts when it's born. Okay. And it grows a full foot every 2 months. Okay, so up 1 over 2. Okay, you could also plot your ordered pairs. After 1 month, it would be 6.5 feet tall. Okay, so that still shows that relationship. Okay, so you could go smaller increments or you could go bigger increments. Both are mathematically correct. Okay, so the process that we did would be starting at 6 and growing a half a foot every month. Starting at 6, growing a half a foot for 5 months, a half a foot for 4 months, for 3 months, for 2 months, for 1 month, and for 0 months. Okay, so it says first, explain how we found ordered pairs to create our graph. Okay, so there's 2 different ways. You could look at the table and plot the table. Okay, or if you're understanding the slope-intercept form, okay, you could start at 6 feet because that's his starting height. Okay, and then you could go up 1 foot every 2 months because that's his growth rate. Okay, so you could either use a table or you could just use the equation that we wrote from the word problem. Okay. What is the slope of the graph and what does it represent? Okay, so slope again is the change in the y over the change in the x. So our y's are changing by a half a foot and our x's are changing by 1 month. Okay, so our slope is 0.5 over 1 or 1 over 2. Okay, both represent the same thing. It's either growing a half a foot every month or it's growing a full foot. I don't know why I wrote inch. Okay. Or it's growing a full foot every 2 months. Both are equivalent, totally up to you and what makes sense to you. Question 3, what is the y-intercept of the graph and what does it represent? So the y-intercept is when x is 0. So the y-intercept is 0, 6, which would be 6 feet, and that would be the giraffe's starting height. Okay. what would the 0.9 comma 10.5 represent in the context of this situation? Okay, so if we would look here, 3, 6, 9, okay, and it is off the graph, okay, but it'd be about 10.5. Okay, so in the context of this problem, it'd be 9 months. The giraffe would be 10.5 inches or feet tall, okay? So 9 months, because that's what our X in our graph looks like. It's the X in our table. It's what the giraffe does. It gets older, and as a result, it gets taller. So at 9 months, the giraffe is 10.5 feet tall. Okay. If the giraffe is 12 feet tall, how many months is it? Okay. So what we could do, I'll show you guys two different ways to do this. We could just extend our table. Okay. So 7, 8, 9, 10. Okay, we're trying to see when is it 12 feet tall. So it's at 9, then it's at 9.5, then it's at 10, then it's at 10.5, then it's at 11. So it looks like it needs to be 11, 12. Okay, so then after 11, it would be at 11.5, and then it would be at 12. So it looks like I went down to the entry of 12, 12. Okay, so 12 months, it would be 12 feet tall. Okay, and I can just look at my ordered pair to figure that out. Okay, we could also look at our graph, but our graph stops at 10, so that's not the most convenient way. Okay, another way that we could do this is feet tall is the output of this equation. Okay, so my equation is 6 plus half x. Okay, I want to know, when does the output equal 12? So I could plug in 12 as my output. And then look, this is just an equation that we could solve. Okay, I would subtract the 6. 12 minus 6 is 6. And then I would divide by the half. And 6 divided by a half is 12. Okay, so you really just have to pick right now the most efficient way that works for you. Equations do work quicker, but if you need a way that works, you could just extend the table to find what you need, okay? All right, so on page 18, it says, use the representations below to find this missing information. So in this problem, we have an equation that's given to us. We have y equals 1.5x plus 12. Okay, we have to fill in the table. We have to fill in a graph. So when I look at the table, it says that x is the number, we have toppings, and the output is the cost of a pizza. And that correlates. We have number of toppings and the cost of a large pizza. Okay, so I'm going to start off with just graphing it because I can graph this. Okay, so this starts at 12, so I'm going to plot 12. Okay, I'm also going to put that at 0 toppings. That means I'm starting with $12. Okay. Now, my slope is 1.5 or 1.5 over 1. Okay, so this is going up by 1. My x's are going up by 1s. So I need to go up by 1.5 in my y's. Okay. So 12 plus 1.5 would be 13.5 or 13.5. Okay, so I'm going to find about 13.5, the best that I can, and go over 1 for that one topping. Okay, then I'm just going to continue to do these. These are continuing to go up by 1s. Okay, so I'm going to continue to go up by 1.5. 13.5 plus 1.5, 1.5 is 15. Then we have 16.5, 18, 19.5, and 21. Okay, so I'm just going to plot this information in. Okay, so we have two pizza toppings would equal 15. 3 would be 1650. 4 would be 18. 5 would be 1950. And 21 isn't on this graph, so I'm not going to worry about graphing it. Another way to do this, instead of using slope, we could just plug in our input. We know all of our inputs and we were trying to find our outputs. So 1.5 for 0 plus 12 would be 12. 1.5 times 1 plus 12 would be 1350. And I continue that pattern, just use my calculator to find these values, okay? But if you feel like you have a good grasp on what slope is, all I did was just increase 1.5 as this went up by 1, okay? Now, another thing that I get a lot is, well, usually we don't like 1.5. Usually we like to convert that to a fraction. Okay, so if you were to type in 1.5 into your calculator, hit enter, and then hit second PRB, you would get 1.5. And then you would hit second ABC again, and you would get 3/2. Okay. This is also correct, okay? And that just shows a bigger spread of my slope, okay? Every time I go up 3, I have to go up 2, okay? So the simplified slope is up 1.5 over 1, okay? But, and in real world context, we can have decimals, but we could just re-simplify the slope to 3/2. You could also do it that way, okay? Okay, so then we just need to have a verbal description. Okay, so it looks like we're talking about pizzas. Okay, it looks like it says a large pizza. So a large pizza costs $12. Okay, and then it looks like every topping costs an additional $1.50. Okay. Okay, so for this last one, we have no verbal description, no equation, no graph. All we have is a table. We have watermelons and we have pounds. Okay, so let's go ahead and let's just graph it first. Okay, so for 5 watermelons, it weighed 6 pounds. So 5 watermelons, 6 pounds. 10 watermelons, 12 pounds. 15 watermelons, 18 pounds. 20 watermelons, 24 pounds. And 25 watermelons, 30 pounds. Okay. So now what I'm going to do is I'm going to go backwards, okay? So if I notice, these are going up by 5s and these are going up by 6s, okay? And I could just use the pattern in the graph to see, okay, this would probably cross at 0, okay? And that is correct, okay? We could also use the table. These are going up by 5s. So if I go backwards, I would be at 0 watermelons. The weight is going up by 6s, so if I go backwards, I would be at 0 pounds. And contextually, that makes sense. 0 watermelons, 0 pounds. Okay, so my slope is up 6 over 5. Okay, so my equation would be y equals up 6 over 5x, and it starts at 0. So you could put plus 0, you don't have to put plus 0. Okay. Contextually, this means that every 5 watermelons, I'm just going to put watermelons, WM, weighs 6 pounds. So this is a proportional relationship because it starts at 0, but contextually we can still write an equation, we can use a table, we can create a graph, and that would basically be it. Okay. You could also simplify this into a unit rate. Because that is 5 watermelons weighing 6 pounds. You could do 6 divided by 5 and get 1.2. So I'm going to also write y equals 1.2x, okay, because that is also correct. And that would just mean that every watermelon weighs 1.2 pounds. All right, so tomorrow we are going to practice this skill. I hope you guys have a great day, and I'll see you tomorrow.